Hello everyone. Today we'll see the determination of saponification value. So the aim of this experiment to determine the saponification number of a given unknown sample. So the saponification value or saponification number represents the number of milligram of potassium hydroxide required to saponify 1 gram of fat under the condition specified. It is a measure of the average molecular weight or chain length of all the fatty acids present, as most of the measure of fatty or tri-star is in the 3 fatty acids. The saponification value allows for comparison of the average fatty acid chain length. The long chain fatty acid found in fats have a low saponification value because they have a relatively lower number of carboxylic functional group per unit mass of the fat as compared to short chain fatty acids. If more moles of base are required to saponify n grams of fat, then there are more moles of the fat and the chain lengths are relatively small. Given the following reaction, number of moles is equal to the mass of oil per average molecular mass. The calculated molar mass is not applicable to fats and oils containing high amount of unsaponifiable materials, free fatty acid less than 0.1% or mono and diacyl glycerol that is greater than 0.1%. Handmade soap markers who aim for bar soap use sodium hydroxide because saponification value are listed in KOH, that is potassium hydroxide. The value must be converted from potassium to sodium to make bar soap. Potassium soaps make a paste, gel or liquid soap. To convert KOH values to sodium values, divide the KOH value by the ratio of the molecular weight of KOH and sodium hydroxide. So, if you see the particular definition of this saponification value, it defined as the saponification value of an oil or fat, that is lipids, is defined as the number of milligram of potassium hydroxide required to neutralize the fatty acid resulting from the complete hydrolysis of 1 gram of the sample. So, soap is formed during the saponification. For example, that is the fat when treated with 3 mole of potassium hydroxide, then reflux it, introducing heat, and then saponification. After saponification, it will give that. After saponification of fatty acid, it will give alcohol plus sodium salt of carboxylic acid. Then the aim then the star of the fatty acid of lower molecular weight require the more alkali for saponification, so that the saponification value is inversely proportional to the mean of the molecular weight of the fatty acid in a glyceride presence. As many oils have somewhat similar value, that is, those in the olive oil series fall within the range 188 to 196. The saponification value is not, in general, as useful for identification purpose as the iodine value. The saponification value is of most use for detecting the presence of coconut oil. For coconut oil, saponification value 255. Palm kernel oil, that is saponification value 247, and butter fat saponification value 225, which contain a high proportion of the lower fatty acid. The presence of paraffin hydrocarbon may be detected as cloudiness when water is added to the ethanolic saponified oil or fat solution. So thank you.